we learned how to solve linear equation. And in class 4, we learned how to graph a linear equation. Today we're going to do class 5, that is writing linear equation. What does that mean? That means if I give you some condition, for example, I give you slope, or I give you a point, or I give you x or y-intercept, I ask you to write the equation for me. And let's do a quick review about the slope and the y-intercept form. This is the slope and the y-intercept form of a linear equation. Y equals mx plus b. And this m is the slope, and this b is the y-intercept. It is the y-intercept, but sometimes we're lazy. We just say slope and intercept form, which means slope and y-intercept form. It's just y equals mx plus b. So for example, if I ask you to write a linear equation with the slope 5 and y-intercept 3, can you write the equation? Your equation will be just y equals 5x plus 3, because here is the slope and that is the coefficient of x, and the y-intercept is the constant term after that x term. So this is the very easy situation if you are given slope and y-intercept. Just simply plug in slope m right in front of x, plug in y-intercept, that's b, and put in here. You get the equation, and that's the easiest situation. So this is the simple review of a slope and a y-intercept form. Now, next one, I'm going to ask you, what about if I give 1 point? I call this 1 point x1, y1, and slope m. Can you write the equation? Okay, if I give you the slope and m, for example, if I give you a straight line or a linear equation or a line that passes through 2 points, 2, 5, with slope -2. Can you write the equation? Let's see. We have the equation look like this: y equals mx plus b. Okay, what does that mean? We have a slope, so far we know slope is -2, isn't it? Because the slope is -2. Let's plug that in. So the equation should look like y equals -2x plus b. Now you'll find that you need to find out b, right? This is something that's unknown. However, you have a 1 point. You have a 1, 2, 5, which is the x and the y coordinate. So you plug in x equals 5, x equals 2, y equals 5, and then you can solve for b. So let's do that. 5 equals -2 times 2 plus b. And so that's a 5 equals -4 plus b. Okay, and then I plus 4, and then so I get a b equals 9. Very good. I got an m, I got 9. So the equation look like y equals -2x plus 9. So you think about this. I didn't give you the y-intercept. I give you a point, and also I give you the slope. Then that line is fixed. All right. So what does that mean is if I give you m slope and a b y-intercept, so when you graph, you can just find here is the b. That's one point. Actually, this point is 0b, isn't it? Right? And then you know the slope. Slope is rise over run. So we just let the run to be 1, and then we just go change the y by m. So I do have 2 points, and then that line is fixed. All right? So this is the slope intercept. If a slope and intercept are given, then the line is fixed. You can solve for that. And then if I give you x1, y1, and I also give you m, that means you are given 1 point. And this point here is x1, and this point here is y1, right? That's the situation. So you're given 1 point. And I give you the slopes. Basically, I'm giving you the direction of the line. So that line is fixed too. When this goes up by 1, and that's the change in y is m, see, you have another point. So given 2 points, then this line is also fixed. So the general idea is when I ask you to write the linear equations, I give you some condition, and that condition is really, they're sufficient. Like I give you the y-intercept, I give you slope, yes, I can find the equation. Or I give you a point, and also I give you the slope, yes, I can find the equation, right? How do you find it? It was exactly just what I just showed you earlier, like this one. Okay, I give you this point, 2, 5, which is, here is just, x1 is 2, and y1 is 5. And then I give you the slope. So what you can do is you can write this equation, plug in the slope first. Then you have this equation looks like there's only b that's you need to worry about. And for this x and y, because this point is on the line, so I can plug in this x, this y, or x1, y1, 2 and 5, then I can find the b. Once I have m and b, I can write this in the slope-intercept form. All right, so we know a lot. The next one, I'm gonna teach you how to write the equation if you are given 2 points. We all know this. If you have 2 points, then you can just draw a straight line, which means you can solve the equation. So 2 points, I call them x1, y1, that's in pairs, right? That's the one pair of the x and y, the 2 numbers, that's the first point. And the second point is x2, y2. And then I ask you to write the equation. How should you do that? Remember, we have the y equals mx plus b format, right? And that is the slope-intercept form. Once you're given 2 points, you can find the slope. The slope is slope. We can do that. That's change in y divided by change in x. Or you could call that rise over run. And how do you do that? The change in y is y2 minus y1. I hope you can still remember this. We learned this in last class. Okay, divided by x1 minus x2 minus x1. So in this case, if you're given these 2 points, first thing, find m. That's the slope. Okay, and once you have the slope, remember we just learned if you're given a point and a slope, you can find the equation. So you have the slope, then you can use either one. You can use this point, you can use this point. It doesn't really matter. You can just plug them into this equation and find B. So you should have exactly the same answer. Let me give you one example. I give a straight line that passes through 2 points. The 2 points are 1, 5, 4, 8. Can you find the equation? If you have 2 points, 1, 5, 4, 2, 3, 4, and 8, which is here. Okay, this point is 1, 5, and this point is 4, 8. Yes, if you're given 2 points, you can find the equation. And we find the slope first. So slope equals the change in y, which is 8 minus 5, right? Changes in y. Later minus, after minus before. So that's a change. And then 4 minus 1, you get 3 over 3 is 1. So you have slope is 1. Now, next, once you have this, which means you have this m equals 1, and the 1x is just x. So your equation should look like this. Y equals x plus b, isn't it? Right? Because you have this m equals 1. And then, like I said earlier, you can use either one. You can use this point or you can use this point. Plug them in. Try the first point. Y equals 5, x equals 1. So 5 equals 1 plus b. And you minus 1 on both sides. I get a b equals 4. So the equation is y equals x plus 4. That's your answer. Okay? And you can also try to put in this. You can put x equals 4 and y equals 8. So you get 8 equals 4 plus b. And then you subtract 4 both sides. You also get a b equals 4. Then you should have exactly the same solution. So this line has an equation y equals x plus 4. Alright, now let's review this quickly. If I give you m and b, which means I give you the slope and a y-intercept, just put them in directly into this equation. You can find it. And the second situation is if I give you 1 point and a slope. So you're given a point, the slope pretty much tell you the direction, right? This is positive, 0 and negative. So if I give you the slope, which means I give you the direction, then you can plug the point and the slope into y m x to get a b, and then you can also get the equation. Now this is the situation that if I give you 2 points, then you can use what we just learned in last class about a slope. That's m. That's going to be the rise over run, or the changing y over the changing x. You get the m, which is the slope. Then you can choose either 1 point, because you have 2 points. You can choose either one, and then put them back into the second situation we just went over to get the solution. All right, so we are very good. We already know quite a lot. Now let's try this. Let's see if you still remember the function, the idea. Remember the function f of x. Now if I tell you f of 1 equals 5, f of 3 equals 11, I ask you to write the linear function. Well, remember I told you that f of x equals y, and this is y, this is x, so which is equivalent to 1, 5 and 3, 11. Okay, so that's 2 points. You just think this is like given 2 points and you can find the equation. And we do m first, slope is the changing y, 11 minus 5 divided by the changing x, 3 minus 1. and that is a 6 over 2. The answer is a 3. Great. I have a y equals 3x plus b, right? Because y equals mx plus b. And I have 2 points. I can choose either one. Remember, I told you choose either one. You should get exactly the same answer. Let's choose the first one. That's x equals 1, y equals 5. So 5 equals 3 times 1 plus b. 5 equals 3 plus b. Subtract 3 on both sides, so you get a b equals 2. b equals 2. Then the equation equals mx plus b. Remember, that's the standard format. Now the standard, I'm so sorry, this is the slope-intercept form. So in this case, y equals m is a 3 plus 2. Isn't it? This is y, but I ask you to write the linear function. This is a linear equation. If I ask you to write the linear function, you should write this. F of x equals 3x plus 2. This is your answer. This is slightly different than the equation. Just ask you to write the linear equation. This is write the linear function. If you're asked to write the linear function, this should be the answer. Okay, or this is the linear equation, this is a linear function. They're pretty much the same thing. Okay. The next condition given, or the next information given is if I give you a graph, can you find the equation? And you should be able to do that. Let me ask you. So this is 0, 1, 2, and that's y. And here is x. So let me go to 1, 2, 3, and 3, 3, 3, 0, 2. If I give you this, here is a 3, 3. This one is 0, 2. Okay, so if I give you the line, if I give you the graph, can you write the equation? Now you might want to take a look at this graph. There's something very good because I know where the line passes through or intersect with the y axis. That's 2. So I already know b, isn't it? Remember, y equals mx plus b, and this b is the y-intercept. In this case, we already know this. Y equals 2. Next, we can find m. M is the slope. The slope is change in y over change in x, or you can say rise over run. And what is rise? Rise over run. Over run. The rise is from 2 to 3, so the rise just go up by 1, so the rise is 1. And the run, you run from 0 to 3, so run is a 3. This is the slope. Slope is 1/3. So y equals 1/3 x plus 2. Isn't it cool? You can find it from the graph, and then you give the equation of this line. All right. Now I give you one more example. That's y and x. Here's a 0, here's a 3, here's a 3, here's a 1, 2, 1, 2, 2, negative 3, things like this. All right, so it passes through this point, and this point again is a 0, 3, and I give you another one, 2, negative 3 here. This is 2, negative 3. This is in the 4th quadrant, isn't it? So I'm going to draw the line. Oh yeah, not very good. Okay, so basically I give you these 2 points. Okay, rise over run, and we know this. So b, we know b. B is the y-intercept, that is a 3. What about a slope? M is rise over run. Okay, we go from this point to this point, always from left to right. Okay, always go from left to right. What is the rise? It's not rise, actually we're going down. we're going from positive 3 to negative 3. So the rise is negative 6. This is the tricky part, okay, when you have a negative slope. And then the run goes from 0 to 2. So the run is 2. So the slope is negative 3. Therefore, the equation looks like this. Y equals negative 3x plus 3. All right. Now this is the example given graph. If you're given some graph, then you can also find the equation. Now, it seems like we have learned so many different ways. One is if I give you m and a b. Second is I give you the point n, m. The third situation is I give you 2 points. And the last one is I give you the graph. So you should know how to write the equation under this fourth situation. Okay. Next one, I'm going to teach you some new form. It's called a point slope. Point slope form. We actually already know something about that, which is if you're given a line that passes through x1, y1, and also with the slope m, can you write the equation? Do you remember how did we do that? We did y equals mx plus b, and then we just substitute this m by whatever number is given, and then we put in this number to find b. Now, actually, there's another form. It's called y minus y1 equals m times x minus x1. Or there's another way to do it, is m equals y minus y1 over x times x1. Did you see that this looks so familiar? And earlier we have y2 minus y1, x2 minus x1, and that is the change in y over the change in x, and that change is from this point x1, y1 to another point x2, y2. Now this x and y, it's a very general form. That's just the variable x and y, and y minus y1, which is any point on the line, is x and y. So this is any point's coordinates minus the given point, or just find the rise and the run from that given point. You get the slope. So this is the same thing as we did earlier, but this is just, did you notice that this is just a rewrite of this? It's the same thing. It's exactly the same thing. Either one you like to remember, that is fine. But this, usually the book call that the point slope form. Okay, so the same situation we had earlier. If I give you x1, y1 is given as 2 and 5, and I give you m is negative 2, for example, I give you this situation, then you're going to write y minus 5 equals negative 2 times x minus 2. Well, this is called a point slope form. What is the point? 2, 5. Did you see the sign? Here, x minus 2, actually, that is minus x1, so x1 is actually 2. So 2, 5, that's a given point, and the slope is negative 2. Okay, so this is nothing new, and we should know this, but if I want to get the I want to get the slope intercept form, then I can simplify this a little bit. I use the distributive property. I get a negative 2x plus 4, and then I plus 5 on both sides. I get a y equals negative 2x plus 9. And this is the slope intercept form. Okay? And if you know that, let me show you how to graph a line given point and slope. Okay, I give you the point and the slope let's see, I give you the point is -3 and 2, and the slope is 1/3. How do you graph that? Let me show you how to graph that. X, Y. Here's a 0, so 1, 2, 3. Here's -3, and here's 1, 2, 3, 1, 2, 3. So -3, 2, which is here. This is a given point. And also I have the slope 1/3. What does 1/3 mean? Rise over run. When run is a 3, rise is 1. Or when x goes up by 1, y only go up by 1/3. So when x go up by 1, y will go up by 1/3. Okay? Or when x go up by 3, y go up by 1. That's my little sign. Okay? So x go up with, this is run, this is rise. So when x go up by 3, so from -3, I go to the right, 1, 2, 3. And the y should go up by 1, which is from 2 to 3. So that's another point I can find. If I connect this, so you can see clearly, rise over run, right? So that's how you graph this. If I give you point to slope, and you can graph that. Okay. Given again x1, y1, and slope. Okay. So what about this one? What about if I give you a point 5, 2, and I give you m equals 0. Right. When I give you 5, 2, which is 1, 2, 3, 4, 5, 1, 2. So this is the point. That's 5, 2. And what about slope is 0? That means when slope is 0 means it's a flat or horizontal line. So you should have this line. All right. Now if you are using this, let me write this again. Y minus y1 equals m times x minus x1. If you're plugging this m, x1, y1, you're going to get a y minus 2 equals 0 times x minus 5. But here, 0 times x minus 5, which is 0. So you get y minus 2 equals 0. Is that the same thing as you get from here, that the line is y equals 2? It's the same thing, isn't it? So, and for the vertical line, if I give you 5, 2, and the m is undefined, then that will be x equals 5. So I'm not going to detail about that. Next thing we're going to learn is called a standard form. We did this earlier. Standard form. If you remember, that's ax plus b, y equals c, and a, b not both 0. Okay, one is 0, that is fine, but they're not both 0. Okay, now I'm going to convert between the standard form to slope intercept form, and convert this within point slope form. This is y equals mx plus b. This is y minus y1 equals m times x minus x1. Alright, so we're going to convert from here to there and from there to here, so we're going to get familiar with that. What do we learn, or we spend most of the time today to get familiar with this? And if you have this, you want to convert, if you have this point slope form, So that's y equals y1 equals mx minus mx1, and then you plus y1 on both sides. You get y equals mx plus y minus mx1. I just skip one step because I think this y1 goes to the right, become positive. This is negative, but this altogether is a constant term, and that's actually this is b. This is b. Okay, so we did from here to here, right? And how do we go from here to here? Let's see. How do we change from y equals mx plus b into ax plus by equals c? Very easy. You just minus mx on both sides. So you get negative mx plus 1y equals b. You compare this with that. This is the standard form, right? So if you want to change from ax plus by equals c, how do you change that into y equals mx plus b form? We want to isolate this y. So I got a by equals negative ax plus c. You see what I'm doing? I minus ax on both sides. Then I divide it by b. So I get a y equals negative a over bx, okay, plus capital C over b. This is the slope, and this is the little b. See? I'm doing forward and backward. So this is how do I work on the conversion of them. And so far we learned three forms of a linear function. Standard form, okay, standard form, this is the slope and intercept form. And for the point slope form that, where was that? Oh, here. Point slope form, usually we don't really use that a lot, but we also learn how to convert it. So far, that's everything about the three forms. We're going to work on something more interesting. We talked about this, parallel lines. Parallel lines. If two lines are parallel to each other, they have the same slope. Or I call this M1 equals M2. This is the slope of the line 1, this is the slope of the line 2, they're the same. What about the other one? The other one is called a perpendicular lines. Perpendicular lines, this means there's a line 1 and here's a line 2, and they form a 90 degree, which is like a right angle. So this is the line 1, this is the line 2. And what is the relationship between their two slopes? M1 equals negative inverse of M2, and vice versa. M2 is also negative 1 over M1. Or there's another way to remember that is M1 times M2 equals negative 1. Okay, so you should remember either one. It's the same thing. So for two parallel lines, and this is the relationship between their slopes. In the future, if you like, you can write. I can show you how to do that. So for line 1, this is the rise over run. Did you see that? The rise over run. But for this one, the rise become negative, and the run is this short side. So rise over run, short over long. But this one is a negative long over short. Okay. I don't know whether you like this way, but it looks like a scissors. But anyway, so this is, I hope you can remember, okay? Or you can remember this, but negative inverse might be an easier way to remember. Now, let me ask you a question. What is the relationship between y equals 6x minus 5 and the other one is y equals negative 1 over 6 plus 8? What is the relationship between these two? The slope is 6, negative 1 over 6. They are perpendicular to each other. Perpendicular. We can tell. Okay. What about y equals 2x plus 1, and I have another 4x minus 2y equals 3. Whew. This one, I have the slope. I only care about slope, okay? I have this slope is 2. And what about the slope of this one? That we need to rewrite this as the slope-intercept form. So I have a negative 2y equals negative 4x plus 3. Okay, I subtract 4x on both sides. Then I divide it by negative 2 so I can isolate y. And everything will divided by negative 2. So that's negative 4 over negative 2 and 3 over negative 2. So the negative 4 over negative 2, which is 2x, and here is negative 3 over 2. And what is the slope here? This m2 is 2. So even they don't look like the same, or you have to do some work, but you still find they have the same slope. So these two, they are parallel lines. Okay? So after we know this, well, you're going to see a lot of math questions like this. I will ask you to write the linear equation that passes a point 2, 4 and parallel to this, y equals 2x plus 1. Can you write the equation of the line that passes through 2, 4 and parallel to this? We know a point. This is the point. Okay. Parallel to y equals 2x plus 1. What does that mean? We know slope. This slope is 2. So if it's a parallel, so we know our slope should be the same. Okay, so we have a point, we have slope. So I can do y minus 4, y minus y1 equals the slope times x minus 2, or y minus 4 equals 2x minus 4. Hey, plus 4, that's gone. So y equals 2x. This is your solution. Okay, so you're looking for a line that passes through this point and parallel to y equals 2x plus 1. Now, very, very similar. Let me ask you another question. Oops. I ask you for a line, equation of a line that passes 2, 4, but perpendicular to y equals 2x plus 1. Whew, here's the point. Here's the point. So, and I need a slope. But this slope, this is m1, that's 2, right? So what about the perpendicular? Two perpendicular lines. The m2 should be negative inverse of m1. So this slope should be negative 1 over 2. Okay, negative inverse. I have a point, I have a slope, so I get a y minus 4 equals negative 1/2 x minus 2. Okay, so y minus 4 equals negative 1/2 x, and the negative 1/2 times negative 2, which is plus 1. And then I just need to plus 4 on both sides. Therefore, I get a y equals negative 1/2 x plus 5, so that would be plus 4, so that it's going to be plus 5. And this is my answer. Right, so this is a very, very typical question that will ask you to find the equation of a line that passes through a point and either parallel to a given line or perpendicular to the given line. And we know that for two parallel lines, they should have the same slope. For perpendicular lines, their slope are negative inverse of each other. Then you get the slope combined with the point you had earlier. Then you can get the equation. And I don't really care how do you give me the answer, but I do hope that you can give me like this: y equals mx plus b. This is a frequently used form of a linear equation. So try to work on this, okay? As long as we get that, then we should be okay. Going to work on some word problems. I just got two word problems. Okay, so if you cannot see clearly, I'm going to read it. In a tax-free state, I don't know where is that, Jason wants to order a pizza. The pizza costs $9 plus 1.5 per topping. If he pays to tip 20% of the total cost of the pizza, write the total payment as a linear function of the number of toppings. Okay, so this one is a linear equation. Of course, if you just new to this, you probably don't know, but in the whole class we did for the past 3 classes, past 2 plus this one, we're doing linear, and I give you the question here, it's a linear. And also I tell you it's a linear function. So which is f of x, right? I need to write f of x. But before that, you have to let x be the number of toppings. Okay, let's see what is f of x. First of all, the pizza is $9. Okay, and for each topping, it's $1.5, so it's going to be 1.5x. This is the total cost of the pizza. It's $9 plus 1.5x. This is the total cost of the pizza. But after that, he wants to pay the tip 20%, which is you have to use this one times 1.2. Okay. 20%, that's 0.2. Okay, if you don't know this, then you probably need to go back to some early classes. And then we just distribute this 1.2. So we got a 1.2, so we have a 10.8, okay? Then plus 1.5 times 1.2 is 1.8x. All right, so your solution will be this: f of x equals 1.8x plus 10.8. Now the good thing about this equation, this linear function, is if I ask you what is the total expense or the total cost for this person together if he just order a pizza with one topping, it's going to be f of 1. So 1.8 plus 10.8. What about this guy is a meat lover? He gets 5 toppings with all the meat, all the pepperoni, sausage, whatever, all meats. So that x will be 5. So that we're looking for f of 5. So f of 5, you just plug in 5 here. 1.8 times 5, that's 9. And then plus 10.8, you get a 19.8. So this is a good thing, right? If you give the equation, then you can easily find what you're looking for. All right, this is the first word problem. All right, we're going to do the second one. You are saving money to buy a new computer. You have saved $120 as of today. and plan to save $50 more each month for the next several months. Okay, so number one, write an equation for the total amount T you will have after sorry, it should be month. Okay, months from now. All right. T, how much money you're going to have? The total amount you have saved. Right now you have 120. And then for each month you save 50. This is the unit rate, right? For each month you add $50 to your saving. And that's the unit rate. In our linear equation part, or when we do the graphing, this is the slope. This is unit change. So for each m month. Okay, so each month is $50. M months, 50 times m, plus whatever you have right now is 120. So this is the answer. All right, now can you graph the equation? When you want to graph the equation, you will do this, m, sorry, and here is a t. All right, now 0. When m equals 0, part is 0, have 120. You start from here. You don't have a negative m. You don't. And when m is 1, you have, when m equals 1, you have 170. And this is your graph of the equation. You don't have anything for negative part. Okay, so you only have that. This is your equation. Now find the total amount saved after 4 months. That is when m equals 4. Don't be confused. This m is not slope. Okay, it's a variable. It's a number of months. So 4 months, then the t will be 120 plus 50 times 4. That's 200 plus that. After 4 months, you have $320 in your saving. Well, of course, for the word problem, usually you're going to answer your questions in words. I just don't think that we need to do that right now. And you should be able to find a lot of word problems in any textbooks, or any teacher will give you like the worksheet to practice. All right, so that is all for today. It seems like we finished pretty quick for this class. Thank you.